Now I mentioned earlier that internal tables are made up of a table body and either a header line or a work area. Well, from now on, just assume we are talking about the newer style internal table, and that's an internal table with a work area. As a nice simple example, an internal table can be made up of just a number of individual fields that correspond to different columns of a table. Just like when you created the data dictionary table, you created the individual fields. And if you recall, when we set up that table, we also identified key fields. Well, the same thing can apply for internal tables, but we have a little bit more flexibility. When we declared our table in the ABAP dictionary, we had to use key fields to uniquely identify every record in the table. Well, internal tables are a little bit different. As well as identifying unique records, you can also specify a non-unique key. This allows us to store any number of non-unique records. So what I mean is, a unique key will specify an individual record in our table that can only appear once. But a non-unique key allows us to have any number of duplicate records we want. The differences don't just stop there. We can define different types of internal tables too. And this is mainly so we can access our data in the most efficient manner possible. What I mean is really fast. So first of all, we have standard tables. Now a standard table gives us the option of accessing the records using a table key or an index. I'll show you how to define table keys and indexes in a little while. When we access records using a key in a standard table, the larger the internal table is, the longer it will take to read the records we want. And this is why we have the option of using a table index. Standard tables don't give the option of defining a unique key, which results in the possibility of having identical lines appearing many times throughout your table. Now, as I just mentioned previously, we don't have to have unique records in our table. So a standard table can hold any number of records that have identical lines. Now, although accessing records using a table key can take a fair amount of time with a standard table with lots of records, there is a flip side, in that a standard table can be filled with records very quickly, because the system doesn't have to check the table key for any duplicate records. And you'll find that when looking at programs and creating your own, standard tables are really easy to define and work with, and you will see that they are the most often used table type within SAP system programs. Now next up, we come to sorted tables. Now, as you might guess, with a sorted table, we can define a unique key. This means we can force all records to be unique in the internal table, thus removing any duplication of records. And like a standard table, we can access records of a sorted table using the table key or using the table index. Another commonality with standard tables is that you can use the table key to find records. Now in standard tables, I mentioned this can be quite slow the bigger your table gets. Well, the same sort of thing applies with sorted tables, but I must say the performance is a lot better. But it's not the best we can get. Now it is preferable to use a sorted table over a standard table. One, because of the increased speed in accessing records, but also because a sorted table sorts your records into a specific sequence. It gives you a performance increase when accessing the data. Now the final internal table I want to discuss is a hashed table. And hash tables do differ from standard and sorted tables in that you do not access the records of a hash table using an index. You will only use a unique key. Hashed tables are normally the preferred internal table when it comes to speed. Now this isn't always the case, but generally it is. When you think your internal table is going to get quite large, a hash table normally gives you the best bang for your buck. And I recommend you use hash tables whenever you think you're going to have large internal tables. See, these types of tables use what's known as a special hash algorithm to ensure the response times of reading records are maintained no matter how many rows of data your table contains. They really are super fast. Now, saying that, you will find that standard tables and sorted tables are used way more in SAP programs than hashed tables. And because of that reason, we'll stick with standard and sorted tables going forward. Before we move on to looking at how we actually create internal tables, the specific syntax, I want to spend a few moments regarding best practices. SAP has been around for a long time, and as such, there are many programs that exist in the current version of SAP software that themselves have been around for many years and conform to using the older style of internal tables in their code. When you create your own programs, please use the newer style. This will ensure your programs will be able to be used well into the future. This doesn't mean you can't use the older way of programming. But if you have a choice, why not use the newer syntax? Because everything SAP is developing right now and in the future will use the newer object-oriented syntax. And as we work through how to create internal tables, I will cover both the old and the new style of coding so that you are familiar with how ABAP has changed over the years. And this will enable you to recognize the old and new style of coding in the programs that you come into contact with. Now that's enough of that. Let's crack on and have a look at some code. I've created a new program that we will use to take a look at how we use internal tables in our programs. Now you will already be familiar with the data statement that we use to declare fields. Well, we use exactly the same statement when we want to declare internal tables. Now when we declare internal tables, we have to define the start of the table and the end of the table. So let's have a look how we do this. So we start with the data statement, and then we use the begin of addition, and then we specify the table name. I'm going to use itab01, and you will see itab being used as a temporary table name all throughout SAP programs. itab01, and then we have to have an occurs addition, followed by a numeric. So what this does is the begin of means we are starting the definition of something, and then we specify what we are declaring. So this is going to be an internal table, and I've named it itab01. Now the occurs clause, if I pretty it up, now the occurs clause tells SAP we are declaring an internal table, and we are declaring an internal table with 0 records. So occurs means this table is going to be made up of a number of records, but we are going to define 0 to begin with and then let the table expand as we fill it with data. So I'll key in the rest of our table definition. Now I'll create a field called zsurname. I'm going to make it based on the field that we defined in our zEmployees table. So first of all, we specify the table name, followed by the field name, which I think is surname. I'm just going to save this and use forward navigation just to make sure I'm declaring it right. zEmployees surname. Next, I'm going to declare date of birth. And again, use the like statement. I do like to keep everything lined up as well. This should have been a comma, not full stop. And then what we do is specify the end of our internal table. So here we use end of and then specify the table name again. iTab 01. And that's it. We've created the structure for an internal table, and we can now write code to fill it with records. Now, as I've mentioned previously, there are two types of declaring tables: the old style, where we use header records, and the new style, where we use a separate work area. Well, just by the fact that we're using this occurs clause, we're telling the system we are going to create an internal table with a header record. Now, just as I've completed this internal table, I'm going to change it, because one of the things I did here was name our fields in the internal table starting with a Z. When you start to create internal tables, you may find it useful to always make sure your field names are identical to the field names in other internal tables or tables from the ABAP dictionary. Now, the reason I say this is because, well, we've already looked at the move statement, which allows us to move data from one field to another. Well, there is another statement called move corresponding, which we will use a little later on, that is used quite often in ABAP programs. And the reason why we use this move corresponding is, well, I'll give you an example. If you want to move 5 fields from table 1 to 5 fields from table 2, and both tables have the same field names, we can just write one line of code using this move corresponding statement, which will automatically search for any field names that are identical and make sure the data contained in the table 1 fields are moved to the corresponding fields of table 2. And the good thing is, it doesn't matter if these two different tables have a different structure. And what I mean is, the fields can be in a completely different order. The move corresponding works it out. It matches the actual name of the field together. And we will take a look at how we do this a little later on. But for now, just bear it in mind and keep your field names the same. So let's just make sure our code is all complete. Do a check. Yes, everything looks good. So now we've seen how to create an old style table with header records. Let's have a look at how we do the new style. So remember, this is the way you want to define your internal tables moving forward, because it complies with the new style of coding and can be used with ABAP objects, which is now the standard way of writing new programs, and you will see lots of ABAP objects code when you dip into standard SAP programs. Now, just so you know, we are not going to dip into ABAP objects programming right now. We're just going to concentrate on how to declare internal tables and structures using object-oriented techniques, because you will see this being used in the majority of programs, whether they are object-oriented programs or not. Now, for those that don't know, the whole thing about object-oriented programming is that we want to keep each part of our program separate from other parts, which allows you and others to reuse all these individual objects throughout your program and in other programs. So in our case, when we create an internal table, we need to separate out the individual data objects, sort of like tiny building blocks. We can then put these building blocks together to create any type of object we want. So put another way, we're making use of modularization and reusability of data objects to enable us to create new data objects later on down the line. Okay, let's have a look at this code. Now, first off, we have to define what is called a line type. And at first glance, when you look at what we're going to do now, you may think this is an awful lot more work than defining a table using the old syntax. But don't worry, It's quite simple, and you will quickly see the benefit of using this when you are dealing with larger, more complex programs by being able to reuse your code. So we start off with using the types statement. And think of this as we're declaring new data types. So just as we have integers, character strings, well, we're using types to declare a new data type. In our case, we're creating structures of existing data types. So back to the code, types, and then you should be familiar with begin of, and then we specify our own name to identify this line type. So I'm going to use line 01 and we'll put underscore typ on the end. Then I'm going to copy and paste. Our two fields, exactly the same. And then I will use end of line 01 underscore typ. So it looks very similar to the old style. Let's add a comment in here. In this statement, we declared a table, so that consists of a line, and also saying to the system, we're going to store multiple lines in a table. Well, here we're just defining the structure of one line. This does not define the internal table yet. We will come on to that. Now, the first thing you'll notice is that instead of using the data statement, we're using the type statement. And of course, there's no occurs addition, because we're not defining an internal table at this point. We are just defining a line of a table. We then declare our surname and date of birth fields, as we did with the old syntax. And just as with the data statement, we use the colon to tell the system we are going to chain statements together, so we don't have to retype the word types all the time. And the last line, we're saying this is the end of our line, by using the end of. Now, once we have defined our line, the next step is to define our table type. Now again, we're not quite at the point of creating the table yet. We're going to say we're going to create a type of table. So we're just defining the structure of it. And again, we do this with the type statement. Then we declare our internal table. So just as we did up here, I will declare an internal table down here. And I'm going to call this itab 02. But don't forget, this is a type that we're doing. So I'm sticking the underscore typ on the end. Then I add type standard table of, and then I specify the line type. Line 01 underscore typ. Now again, as I mentioned, we've used the type statement instead of the data statement. We give our new type the name, itab02 underscore typ, and then we follow this with the word type to indicate we're going to define our table based on a type that already exists, which is this one. Then we include the term standard table of to indicate we are going to create a standard table type. Now remember, a standard table can have multiple identical records. meaning we have no unique key. So that means we don't have to include any unique key in this table type definition. We just need to declare it just as we did. Also in the old statement, we use the occurs clause up here to define the initial size of our table, and we use 0, which meant really we don't know how big the table is going to be, so just leave it up to the system to determine it. But in this new style, using the types, instead of using the occurs clause, we can add initial size, and then we can give it a number. So it could be 0. But this is completely optional. And if you don't know the exact size of the table you are creating, you can just leave this off. And actually, you very rarely see this in programs. So just leave your statement like this. And lastly, let's also consider how we can create a sorted table type instead of a standard table type. Now, before moving on from this statement, let's also consider how we can create a sorted table type instead of a standard table type. Well, we can do this by, I'll tell you what, I'll just copy this line so you can see the difference. So where we have our type defined, we just go past the type statement, and here we can have sorted table of line 01 underscore type, and then we specify our table key. So because our table is made up of surname and date of birth, we can then say with unique key, and then we can add a key. So we can put surname. It's just gone on to 2 lines, so let's put this like this. So you can see it's very similar, but we're saying, with the proper words, we're creating a sorted table instead of a standard table. And because we're going to create a sorted table, we need to say what we're going to sort the table by. So we're going to say we've got a unique key, and we're using the field surname, which is part of our line type. Sorry, which is this one there. Now this is just an example because we know that the table we created and the records we have in there, we actually have duplicate records based on surname. So later on, when we create a sorted table, we will specify a unique key where we will use more than one field that defines the unique record. And just to show you how you can do that now, all you need to do is list the fields at the end of the statement separated by a comma. So because our table only exists in 2 fields, in this case I will just say comma DOB. Okay, next up, remember we have still only declared types at this point. So next we want to declare the table itself. So as the comment says, we're going to declare our table based on our table type that we just declared up there. Let's make it so it works, so we'll just comment out the sorted table. So up to now, we've defined the line type, and then we've defined the table type that is based on the line type. But all these are just type definitions. We've just created the blueprints to make up a table. We do not have an internal table yet. So how do we do this? Well, let's have a look at the code. And it's really, really simple. We use the data statement again. And then we declare now our internal table name, followed by type. And then we specify, tell you what, let's change this. And then we specify the type our table is going to be based on. So because we've already defined our line type and our table type, all we need to do now is use the data statement to say we're going to create a new table called itab02 that is based on the table type we declared itab02 underscore typ. And when declaring internal tables this way, we have the option of whether to use a header line or not. If you do want to use a header line, you must specify this explicitly in the data statement. So it would read, let's have a look, data type, and then you would say with header line. But remember, I'm saying don't do this, because if you do, you'll not be able to use this style of table in ABAP objects. So the next thing to do, let's get rid of it. Now, we're not done quite yet. The last thing we need to do is define our work area. And we will use this work area in conjunction with the table we've just defined. Now, before we put the code in, just note that the work area is actually not part of the internal table. We have actually declared the complete internal table now in the previous step. But we declare our work area to work in conjunction with the table, meaning we move data to our work area, we work with it, and then we update our table from the work area. Or we read data from our table into our work area to allow us to work with it. The work area is completely separate. And because it is separate, if we have multiple internal tables with the same structure, we can also use one work area to read and write data to and from multiple tables. And that's an example of reusing your code. So let's have a look how we define the work area. So once again, we use the data statement. And I'm just going to call this now WA, stands for work area. And it's going to be a work area that we're going to associate with itab02. Now, the association is just in my mind. It's not anything in the system. So it's just, a mental association. So I'm just going to say WA underscore itab02. Just so I know what work area matches what internal table. Then we use the word type, and then we have to specify the line type. Well, we've already declared it up here. So we can just copy and paste and bring it down. And that's it. That's how we declare our work area. Use a data statement, we give our work area a name, and we specify the type as the line type we already declared. And that completes everything we need to work with our internal table now. Now I know the first statement of declaring an internal table with a header line was only 4 lines of code, and we had to actually use 7 lines of code to use the new style of internal table. But believe me, it is much better to code this way. And just as an example, we want to create a brand new internal table on the same structure. Well, all we need to do is this. itab03 using the O2 line type. And it can go on and on. We can create 10 internal tables, all based on the same line type. So that's how we can reuse our code. When we read and write data to an internal table that has a header line, we always move and read data from the header line itself. So what I mean here is when we read a record from an internal table, the record is moved to the header line of the internal table and we access the header line. When we want to write a record to an internal table, we move the contents to the header line of the internal table and then the header line gets appended to the table itself. Let's get straight on to the ABAP code and see how we can populate our internal table. So at the moment, the code we have from our previous video is not quite suitable for this example. So I'm going to, I'll probably pause the video a little bit here, declare a brand new internal table, and then we'll have a look at the code. Okay, so I've created some new code, and you'll see it's fairly basic. I've included a table statement to declare the table we're going to be accessing, and then created a brand new internal table with almost the same structure as our Z employees table. So we have employee, surname, forename, title, date of birth, but I've then added an extra field called LOS, which stands for length of service, which will have a default value of 3, something like 3 years. So now let's take a look at how we fill this internal table. And to do this, we will use a select statement. So we start with select. And you can write all on one line here, but I'm just going to break it up so it's a little easier to see the components of the select statement. Okay. So let's break this down. We have our select statement, and the asterisk means we're going to select all fields, and then we say from, and then our table name. Then we're going to say into corresponding fields of table itab 01. So this means select all the fields from Z employees and move them into the corresponding fields that match by name of our internal table. Now this is what's called an array fetch. So it picks up the records and puts them in our table all at once. So before you've seen how we use the select statement as a loop, where it'll do one record at a time. Well, this way of using it does it all at once as an array fetch. And you'll notice there's no end select statement. So as you can see, it's super easy to move all the records from our database table into our internal table. Now, our internal table does have an extra field, length of service. So what will happen here is that every record will be filled with a value of 3. I will add one more line of code just to help with debugging. We're not really bothered about seeing the output, but it will just let us pause the code and interrogate the internal table in the debugging session. Okay. Oops, I pressed the wrong button. Do apologise. Do a check, everything's good. Pretty it up. Stick in our breakpoint. Sorry, I didn't activate. Breakpoint, and now we can test. So we're at the line of code where we're going to fill our internal table. So what we'll do is have a look at the internal table first. And we can see this hat symbol represents a header line. And then down here, you would see all the records as they get filled into the internal table. But as we have yet to process this line, there's nothing there. So I'll just step through the code, one line at a time, and all we should need to do is execute just this one line. And as you can see, I'll just come back up, we executed that. The system did an array fetch and populated all the records into our internal table. Let's change things around a little bit And I want to introduce the append statement, just to give you an idea of another way of filling an internal table. So I'll take the breakpoint off. Let's change around the select statement. And what we will do is create a select loop. And also, because I don't like typing much, I'm just going to bring in my favorite text editor. Oops. And I'm going to say move Z employees dash field name to iTab 01. Okay, saving my fingers. Oops, that's not where I wanted it. Oh, of course, we don't have that field in the table, so I just remove that one. Okay. So what we're doing here is a little bit different. Where instead of doing an array fetch, collecting the data one record at a time in a select loop. So the first record will be selected, and then we have individual move statements to move our data field by field to the corresponding data in our internal table. So let's activate it. I'll stick a breakpoint in, and then we can debug the code and see how it works line by line. Okay, so I'm going to step through. Let's bring up just iTab 01 and we'll look at the complete table. So it's executed the select statement, and that's just held in SAP's memory at the moment. And now we're going to execute the individual moves. And as you can see, the first move moved the value of the employee field to the header record of our internal table, and so on with the other fields. Now, one important thing is, I mentioned before, when using header records, the system only works with header records. And what I mean is, it's filling the header record, but there's no code to then say, append the completed record to the table. And you'll see this as we step through. We come to the end of the select, start the loop again, and now all it's going to do is overwrite the header record. Now this is a real common mistake made by programmers, and I still make it today if I'm ever using a header record. I'll just sometimes forget to append the records to the table, because everything looks right, it's just you've got this extra line of code that you need to add to say move the header record to the table and then do the loop again. So let's zoom through the code, come back and then see what we need to do to complete this. Take off the breakpoint, and it's really simple. All we need to do to get the header records appended to the table is add our append statement. So just below the moves, I will do append iTab 01. This will tell the system to take the values from the header record and add them to the body of the internal table. Let's have another quick debug so you can see it working. Okay, I'll step through again, one line at a time. Let's have a look at ITAB first. Now we get to the append statement, and you can see a record was added to the body of the table. Now note here, the header record still contains the values. That's something to be aware of. Ideally, you want to clear out the header record as soon as you've added your record to the body of the table. Now also, if we go back and look at the individual fields of the table, and we'll take a look at the length of service field, you can see the default value of 3 has been appended. So we can zoom through the program and get back to the code. We're now going to take a look at the move corresponding statement that I mentioned a little earlier in one of the other videos. There's not much to talk about, so let's just get straight down to the code and show you what it does. So in our previous example, we moved the individual fields to the header record of our internal table and then used the append statement to write that header record to the table. Well, instead of writing those 5 lines of code, those move statements, we can just use one line, and that's by making use of move corresponding. So here's how it looks. We have the move statement, then we have dash, then we specify the table name, which is our Z employees table. Then we just say we want to move it to our ITAB table. And that's all there is to it, and we can get rid of these remaining move statements. So it matches up the technical name of each field from the Z employees, and where there's a matching field in ITAB 01, it'll move the contents. It's really simple, and it's a real time-saving statement. And all you need to make sure is that the fields that you are hoping to move are named the same between the two tables. There is one thing to watch out for, and that's when you use this statement, just ensure that the fields you are moving data to and from do have the same data type and length. So even though it'll match up the field names, it's up to you to make sure the field type is correct. If they do differ in any way, you could end up with unpredictable results. Now back to this code, let's stick a breakpoint on and see it in action. Have a look at our internal table, and then we'll step through the code. Bang, it moves all the fields. So if we scoot up, and I just type in the fields here. Oops, I missed the ITAB. ITAB 01. There, you can see it's actually moving them in. And it's as simple as that. And so on. I'll zoom through the program. Let's get back to some more ABAP. What I'm going to do now is just go through another example. It's the same stuff what you've seen, but just different ways of populating internal tables. So we'll go back to using an array fetch, which means we can use the select statement but without doing a loop. Blocks of data are transferred all together instead of one record at a time. Now at the same time, we're going to create a new internal table as well, but show you how you can create a new internal table using other statements of ABAP. So what I'll do, I'll create an itab2. We'll keep the occurs 0, but this time, instead of specifying all the individual fields, I'm going to remove those and use an include statement. So I'm going to say include structure of itab01. Ooh, just one little error, sorry. Oh, 2 little errors. And also, I need another data statement because I used a full stop. Okay. So notice here, I am declaring the contents of our new internal table using the include structure statement. This just simply copies the structure we declared for itab01 and includes it in itab02. We could also use the structure of a table that we declared in the data dictionary. For example, let's do another one. Let's do itab03. And instead of the internal table, this time I'm going to say bring in the structure of Z employees, if I spell it correctly. Using this method to declare fields of an internal table can save additional coding and can be enhanced further by including multiple table structures all within one single internal table. Let's have a look how we do that. Let's do another one, itab04. So here we have the include structure of Z employees. I can then take, well, add another include structure of itab01. So you can see you can use this include structure statement to add various structures you have already defined or have already been defined in the system to build up your own internal table. Now this, I guess, isn't a great example because we actually have employee defined in both of our structures. So, you know, make sure your field names are unique. But you get the idea. You can just continue adding more structures, or, if you wish, include some more data statements, such as employee count of type integer. Using these techniques, you can build any internal table you want and at the same time reuse your own code. Now let's keep things simple for now. So we'll remove some of these internal tables that we've created and stick to our original one. And I'll tell you what we'll do. We'll go back to the array fetch method of populating tables by taking away this move corresponding. Well, I'll tell you what, I'll keep that there to save me typing. notice I'm deleting the append and the end select. It would help if I could spell fields correctly. So what I want to do is I want to run through this again because this is quite an efficient method of filling your internal tables. You see, using an array fetch, we are not populating our table line by line, and we are taking away the loop generated by the select statement and end select statement. Instead, this select statement selects all the fields from our data dictionary table and moves only the fields that correspond from that table to the fields in the new internal table. This type of select statement is much faster than using a loop. And also, take note that we did not make use of any header record here. There was no need to use it because we used a block by block array fetch method to fill our table. I'll also mention that you can identify the individual fields you want to move from your source table instead of using the asterisk that represents every field. So for example, where we have the asterisk, we could then write out the field names: surname, forename, date of birth, etc. We will now switch tact and have a look at how all this works where we want to use a work area instead of a header line. The fundamental difference is that when we are selecting records from the table, we are using the separate work area instead of using the internal table's own header line. Let's go straight to look at some code. So what I'm going to do is define a brand new internal table. In fact, let me clear out this stuff, because further down in the program we got the stuff we declared before. So first of all, as a refresher, we have the line type, and that's made up of two fields, surname and date of birth. Then, let's put a space in here. Then we declare the data type, which is made up of the line type, followed by declaring the internal table itself. Let's get rid of this one. So this is the declaration of the internal table. Then finally, we declare the work area. So with those statements in place, let's move on and have a look at the select statement we would use. It's very similar to how we define the select statement for working with an internal table with a header line, in that we start with the select statement, and then what I'm going to do here is specify individual fields. So I'm going to say surname and date of birth. Then we use from to say where we're going to select it from, and we're going to specify the employees table. And I'll just break the statement onto a brand new line. Then we're going to use into, and this is where we specify the work area. So because our work area is WA itab 02, that's what I'm going to input. Now I'm going to add an append statement, and this is where I'm going to do WA Let's check the code. Always good. So now let's explain it fully. So we have our normal select statement. We specify it is going into our work area. Then we have our append statement, and we're going to say append the record from the work area to our internal table. Then this section of code is ended with the end select to complete the loop. So let's debug the code and you can see it in action. Oops, not active. Okay. So here we go. There's our work area. There's our internal table. And I'll step through line by line. Work area is filled, and then we append it to the internal table. And then the loop continues. I'll zoom through. Fairly simple stuff. In some of our previous examples, we looked at using an array fetch, which in essence skipped the header record. Well, the same thing applies here. Even though we are using an internal table without a header record, we can still take a look at the same type of code. And see how it works with this type of table. So let's comment out this. And let's now just code a simple array fetch. So we would have the select statement. Let's choose all fields. So we select star from Z employees into corresponding fields of our table, which is itab 02. We don't need the append or the end select. So as you can see, an array fetch works exactly the same as before, and we can test it out. Well, if I stick a breakpoint in, it's going to zoom straight through, but we can see that the internal table is empty at the moment. As soon as I press F5, the program is going to end. But on the F5 press, the internal table will be filled with data. I guess what we need to show that is then just create a bit of code. We will come to loops later on, so don't worry about that. Okay, let's test it again. Have a look at itab 02, press F5, and you can see we've got 5 records inserted into the table all in one go. So I'll just zoom through the rest of the program. We don't really need to look at this output. And get rid of the breakpoints. So we have learned how to create and fill a standard internal table. Let's have a look at how we would use that data line by line. Now, our internal tables are just tables that are held in memory, and similar in many respects as tables that we hold in a database. So let's take a look at how we can read through the records of an internal table line by line using a loop. The way we access the records of an internal table is different to how we access records of a standard ABAP dictionary table. Instead of using the select statement, we will use the loop and end loop statements. The loop and end loop statements are very similar to the select and end select statements, in that we start our record selection with a loop, include any ABAP code we want inside the loop to process the records that we have selected, and then we end our loop with the end loop statement. So let's take a look at how this works with an internal table that has a header line. And I'll change the screen to bring up the header line examples we've used in previous videos. Okay, we have our original example where we are using a select statement, using the append statement to add the records to the internal table, And then we do have a write statement just to help with debugging, but I'm going to remove that. So let's have a look at how we would write this loop statement. It's very simple. We will start with a loop and we say we're looping at our internal table, which is iTab01. We then add code inside our loop to do whatever we want, maybe updating records in another table or writing out to the screen and so on, or maybe just performing calculations. And then once that's done, we have the end loop. So when we access records of an internal table using a header line, each record gets transferred one record at a time from the body of the internal table into the header line, so that we can then work with the header line to do what we want. As you can see, it's very simple and easy to understand. So now we have our loop. Let's fill some code in, just here, so that we do something with the data. So we're just going to write it out to the screen. And it's as simple as that. Let's pretty it up. So as you can see, it is very similar to how we have used the select statement a little higher up. We select our records. We process the data, and then we finish the select. Let's have a quick look in a debug session to see how the header line gets filled and used within our loop. So we'll activate the code, stick a breakpoint on, and execute. So the select statement has already been processed. As you can see, we have, let's see, 5 records. And you can see the header line has still got the 5th record already populated. But when we process our loop statement, we start to loop through the table one record at a time, starting at the first record. And what will happen is this record will get copied to the header line, and then we access the header line with our write statement to write the individual fields out to the screen. Let's go one line at a time. So as you can see, the first record has been copied to the header line, and when we have statements to work with this type of table, they will always access the header record. Have a look at the screen. Amy Jones. And so on. I'll zoom through. There's the output. Real simple stuff. So we've looked at how we can loop through an internal table. Now let's have a look at how we can update the records in the internal table using the modify statement. I will add in some code, and whilst I'm writing it, see if you can work out how it all fits together. It's fairly simple, and then we'll go over it line by line. Okay, it's a very simple change. You can see I've included an if statement and also a modify statement. The if statement allows us to determine if the employee's surname is equal to Jones. If it is, we're going to update that record with the surname of Smith. Then we have an end if statement. In fact, let me change this code. That shouldn't be there. It should be there. There we go. So if the if statement is true, we then have the modify statement, which will take the contents of the header line that we have just updated and update the record in the internal table that was originally read into the header record. Now the modify statement has some specific features when used inside a loop for an internal table. So in our case, the modify statement only changes the contents of the existing line in the internal table that we have read. It does not create a brand new record. If the modify statement is in a loop, it is always the current line that is changed. But please note, you should not do this if you are trying to modify key fields of an internal table that use a unique key. If the modify statement is used outside of a loop, we must specify the record index number that we want to modify, because we have got no index number being monitored by the system automatically, like when we have our code inside a loop. Now a little note is the way we use the modify statements in our example here. We can only use it this way with index tables and tables with header lines. Let's continue on with this example where we have modified the table, and I want to introduce a new statement called describe table. The describe statement can be used to find out information about the contents of an internal table. This includes a number of records the table holds, the reserved memory space used, and the type of table, if it's a standard table, sorted table, or hash table. But in the years I've been using ABAP, I've only ever seen this statement used to find out how many records exist in an internal table. So let's concentrate on that one. Now the way we do this is very simple. We just type describe table, which is the actual statement, followed by our internal table, which in this case is itab01. Then we want to know the number of records. So what we do is use the addition of lines. Then we have to tell the system how we want to store this value. So let's use a new variable called line count. And up here, I'll make sure we have a data statement called line count with a type I. So this statement will return an integer value that represents the number of lines contained in our internal table, and the value will be stored in the variable we defined. So why would you want to know this? Well, we have covered the append statement in a previous module. So you should know that the append statement only adds lines to the end of a table. Now instead of using append, we could use the insert statement. Now the insert statement allows us to insert records into any position we choose inside an internal table by specifying the table index number. If we wanted to insert a record into an internal table at record number 10, for example, we would specify index 10, which would then insert our new record between the 9th and 10th record. And we would do this simply like this. We declare the insert statement, the internal table we're going to insert a record into, then we specify the index number of the record that we want to insert our new record into. And this is where we can use our line count, which holds, in this case, the total number of records in our table. Therefore, the result of these two statements, the describe and the insert in this case, the system will insert a record before the last record in the internal table. So like I said, if there's 10 records, line count will hold a value of 10. The new record is inserted between the 9th and 10th record. And that's why our new record would be inserted one record before the end of the table. Okay, now I've got those silly bugs out of the way. I'm just going to edit this a little bit so this program makes a bit more sense. And what I'm going to do is move this loop to finish here. And once we've gone through every record, we'll then come on to these two statements. So I'm going to set breakpoint. And we'll debug it and see how all this works. So we've looped through iTab. I'll double click it and you can see we have 5 records still. And if we have a look at the value of line count right now, it's 0. So we'll execute this row of code. And now it's telling us we have 5 records. Then we come to the insert statement. And if I flip back to iTab 01, and we'll just scroll down so we can see what happens here. Now remember, our header record has this value in it, 1, lots of zeros and 6. And this is a standard table, so we are allowed duplicates. So when the insert statement gets executed, hopefully it's going to insert a line right here. Now it's going to be difficult to see because the record's exactly the same as the 5th one. So what I'm going to do is change this header record. I'm going to change the value of some of the fields just a little bit so that you can see the record being inserted. So I'll change employee number. To 7. Oops, I pressed the wrong one by the looks of things. Here we go. And let's change surname to Stevens. Okay, back to the fields. I'll have a look at the table. Go to the top. Now we can see our header record has the 1, lots of zeros and 7, and the surname is equal to Stevens. So now we will insert this header record into the table at position 5, which, if you remember, is the total number of records in our table. So we'll execute it. Oh, silly me, I didn't have anything after. Let's run it again. Do apologise for that. So once again, there's line count. Go 1 line of code down. It now contains 5 records. We will have a look at iTab 01. We'll go in and amend the header record again, which is this one. So if I just come down here and say iTab 01, surname, iTab 01, employee. Change that to blogs. And this one I'll change to 7. Oops. 7 there. So if we have a look at the internal table, there's our header record with the new data we've just added. Scroll down, and then when it executes the insert statement, we should have another record inserted here, and this record should be moved down 1 position. And there we go. That's the insert statement. The loop statement is great for looping through all the records of our table. But there is another statement we can use to access the records of an internal table. This statement is called the read statement. And this statement allows you to specifically read individual records from a table. So in our case, because we are using a header line, when we use the read statement, the record will be read into the header line of our internal table. When you use the read statement in your program, you've got to be aware of how your internal table has been declared, because that will affect how you write your read statement code. And what I mean is, what type of internal table are you working with? Is it a standard table, hash table, etc.? If you're working with a standard table with a non-unique standard key, then you would write the read statement like this. Read table, then we specify the table, which is itab 01, and we can specify the index number. This means we're reading the 5th record of our internal table into our header record. The beauty of using the read statement is it is the fastest way to access the records of an internal table, and using the index specifically is the fastest form of this read statement itself. This type of access is about 3 times faster than using a hash algorithm, which, as I've mentioned previously, is our best performing internal table when dealing with lots of data. As well as being 3 times faster than a hash algorithm, it can be up to 14 times faster than using a normal table key. But the problem is we don't always know what the index number of the record is that we want to read, and that's why we nearly always end up using table keys. So let's add an internal table to our code and define some key fields as our table key. So the way we write a read statement using a table key is again read statement. I'll tell you what, I'll pretty it up. Oops. Okay, we have read table, then we specify our table name, but instead of using index and then the index number, what we do is type with key, and then we specify our key fields. So I just go onto a new line and we'll indent it a little bit, and because our itab 01 is made up of these fields up here, we will say our key field is employee. So we would say employee equals, and then we specify an employee number. Simple as that. You are not just limited to using a unique key. You can use other fields as well, but the problem there is that it is difficult to know exactly which record you will be reading. Because let's say if we use the surname field and we add 3 people called Smith, well, you wouldn't know which record has been read. Is it the 1st, 2nd or 3rd? Well, with a non-unique key, the read statement reads sequentially through your table, so actually you'll get the first record that appears in your table that matches your key. But again, you won't have a clue if there are any more records that match without adding extra code to carry out some extra checking. You know, such as check to see if the record was found. If it was found, read the next record. And again, see if that record was found. You know, that type of thing is the only way you'd know if there are more records with the same key. Now this read statement we have just seen can also be used for sorted tables and hash tables. When you specify the key fields to use in your search, the system will run a binary search for sorted tables and use a hash algorithm for hash tables. If the fields you choose to use are not key fields, the system will carry out a sequential search for both the sorted and hash tables. Next, let's take a look at how we can delete records from our internal table. And it's really simple. We just use the delete statement. And we can use the delete statement to remove individual records or groups of records from our table at any one time. The fastest way of achieving this is by using the table index, just like we did with the read statement. But note, this only applies to standard tables and sorted tables, not hash tables. Only these two types of tables have an index. So let's have a look at the code. So we start off with the word delete. We specify our internal table, and then we just give it an index. It's pretty simple. We make no use of the header line here. Instead, we just directly address the record index of the record we want to delete in the body of the internal table. And with the delete statement, we can also use it inside a loop with exactly the same type of syntax. So for example, let's copy this loop and we'll paste it down here. What we can do is, if we have some logic to identify a specific record, in this case if our surname equals Smith, we can then say delete a record from itab 01. We're going to use the index, but instead of specifying the number, we can use a system variable called syindex. And when we are inside the loop, this variable gets updated automatically by the system. So if we are in the 5th iteration of a loop, this variable will contain the number 5, which will equal the 5th record in the table that we want to delete. One thing to note is that you shouldn't use the delete statement without the index addition. If you are outside the loop, you will be given a runtime error, which in turn will cause your program to crash. If you are inside the loop, you need to make sure the index addition is included to be compliant with future releases of the ABAP syntax. I want to introduce the where addition to the delete statement, because there are times when you don't know the actual index of the record that you want to delete. When your table has a non-unique key, you need to use some other logic, as we've already discussed, to determine which record or records you want to delete. And this is where you can use the where addition. Now you use the where clause to construct a logical expression that contains the various conditions that will help you identify the record or records you need to delete as uniquely as you can. Now always try and be as specific as possible when trying to identify records you want to delete, because the last thing you want is to delete data that you shouldn't have deleted. So let's have a look at the code. It's real simple, and what we're going to do is copy this statement here, and we'll bring it down and we'll edit it. So we have delete, then we have the table, but instead of using the index, we're going to say where, and let's use surname again, where surname equals Smith. You can see it's very straightforward. And we have just included one logical expression that attempts to identify any records with the surname Smith that we want to delete. When a record is found that does match our logical expression, the record will be removed from the internal table. If the system finds multiple records, all the records will be deleted that match the expression. Our next topic is all about sorting records in our internal table. So it's probably not going to be a shock to learn that the statement we use to sort our data is actually called sort. And the basic format is really, really simple. Let's have a look. So all it consists of is sort and then the table name. As you can see, the syntax is super easy, and in this case, because we have got no additions to the statement, our internal table will be sorted in ascending order based on the defined table key. Now this works for sorted tables and hash tables. If we are using standard tables, then you are required to use the by addition. And that would look like this. We just add the word by, followed by the fields we want. In this case, I'm just specifying one field. And by specifying the field name, the internal table will be sorted in accordance with the contents. Now don't forget, SAP caters for all sorts of languages, and we need to take that into account if we're working on programs for a company where their systems are used throughout the world. So to ensure your internal table is sorted according to language-specific criteria, use the As Text addition directly after the name of your internal table. So then we build up this sort statement just a little bit more by using As Text. Now our sort statement, is just using one field right now, but you're not just limited to one. You can list up to 250 fields to use in your sort statement. Now I've never seen anywhere close to that being used. But just to show how we can extend it, we can say sort by surname and then by forename. And note, there's no need for a comma separator. All we do is a space and then list our fields out. Now just one extra thing is we've specified as text in our sort statement, and because of where we placed it within the statement, this country specific sorting is going to be applied to all fields that we specify. If you only want the as text addition to be applied to specific fields, you need to repeat this addition after every field in your list. So let's say we just wanted as text to apply only to the forename. We would remove it from this point and then place it after our forename field. Now let's stick with the just the one sort statement we have in our example, and let's discuss the sort order. Now the default is for our sort statement to sort our records using ascending order, but we can, if we wish, specify ascending or descending within the sort statement itself. And we do this by sort itab01, and then this is where we would specify ascending or descending. So if we wanted it in reverse order, we would include the word descending. Nice and easy. And that's about it for the sort statement. So now we have gone through how to fill, modify data, delete data from our internal tables that have a header record. Let's now swap over and look at internal tables that don't have a header record. The ones we want to use going forward, and they're the ones where we specify our own work area. Now we're not going to go through every example again, but what we will do is go through the differences. So first up, let's have a look at reading data. When we have a loop statement that loops through our internal table that uses a work area, the loop reads each record from our internal table into the work area, instead of the header line. Now because we have the ability to specify the work area completely separate to our internal table, we must specify that work area we want to use within our loop to read the data into. So let me clean up this code and have a look at some examples of using the work area with loops and so on. So I've loaded up the code that we've used in a previous example when looking at work areas. And we already specified how to use a work area in an example, but we didn't go into great detail. So let's do that now. So here is where we add an array fetch. We're not too bothered about that right now. Let's remove it. I'll tell you what, no, we'll keep it in because that fills our internal table. Let's concentrate on this piece of code right here. So as you can see, it's a standard loop statement. We're looping at our internal table, but we're going to, instead of using the header line, we're going to read our record into our own predefined work area. And then when we want to work with any data that belongs to the work area, we reference the work area directly. So our write statement says write the surname field from our work area, not the internal table. Now to modify records, the modify statement again has to reference the work area. So I'll bring in an example from using the header record and we'll modify it to use the work area. So we're using itab 02 in this case. So if the surname is Jones, oops, sorry, I need to specify the into. So we would then say if WA itab 02 surname equals Jones, then we would modify the work area record to say Smith, and then the actual modify statement itself would be modify itab 02, and then we would say from our work area. So to summarize, we are telling the system to modify our internal table using the record we hold in our work area. Now the insert statement follows similar lines. Let me bring in the code from the header record example. Here we use the describe statement to find out how many records in the internal table and hold that value in line count, which I will declare again. And it looks like I got the last example wrong because I specified the work area incorrectly. It'll teach me to check my code. So back to the insert. The describe statement holds the number of records in the line count variable. Then the insert statement would say insert a record from our work area into our table using the index position held in line count. So the syntax is a little bit different from standard, where we actually say, first of all, insert our work area record into our table, rather than specifying the table first, like we did with the modify statement with the work area second. But nonetheless, it's still relatively simple. Let's now take a look at the read statement. And as you can probably guess, the read statement follows a similar logic in that we must use our work area with our read statement. And if we go straight to the code, we can have a look at how we write it. So we would say read table, and then we specify the table we want to read, which is itab 02. We specify the index of the record we want to read. But instead of leaving it there with a full stop, we continue on to say and store the record into our work area. Now, just like in previous examples, quite often you do not know the index number of the record you want to read, so you would use the with key addition. So the way we write that is, instead of using the index again, we do read table, internal table, which is itab02, into our work area, and we specify with key, and then we specify the key we want to use. So in our case, let's use surname equals Smith. So just as before, when we specify the work area we want to read the record into, the same thing happens here. The record is transferred to our work area based on our key to allow us to continue with the rest of our program. Now, I mentioned previously when we were discussing the read statement with internal tables that have header lines, you need to keep in mind that tables without unique keys can have multiple records that match the criteria you specify with your read statement. Now, the last piece we want to look at in this small section is the delete statement. And if you remember back when we discussed the delete statement earlier, we mentioned that we didn't use the header record to identify the record we wanted to delete. We just specified the table index. And exactly the same syntax is used for internal tables that use work areas. Because we're not touching the header record at all, we don't need to touch a work area. So there's actually no difference. The same syntax applies in both situations. This next topic is going to be quite small, and it's important that you know about it. And this is deleting internal tables. First of all with header lines, and then with work areas. When working with internal tables, you will see that there are many occasions when you want to delete all the records of the internal table in one go. And this obviously depends on the specific task you're trying to complete with your program, and whereabouts in the program flow you are. As an example, if you were to fill an internal table whilst you were inside a higher level loop, more often than not, you will need to make sure your table is empty at the start of the loop, so that when the next iteration of the loop comes around, you are not left with any records from the previous iteration. Now, there's a certain sequence of tasks that you should really adhere to when deleting the contents of an internal table with a header line. First, you have to make sure you clear out the header line, then make sure you clear out the body of the internal table. So let's have a look at the code and see exactly how we would do this. So I've loaded in one of the previous examples where we fill an internal table. And it's very simple. There's our internal table. We have a select statement to fill it, then a simple write statement to help with debugging. So now, once we've used our internal table, we want to clear it out. So first of all, clear out the header line, and we use the clear statement. Very simple. And all we do is say clear and then the table name. And this will clear out the header line only. By specifying the internal table after the clear statement, the header line will be wiped clean, meaning all fields will be set to their initial value. Then, to deal with the table body that contains all your records, we use the clear statement again, but this time we use 2 square brackets at the end of the table name. So all we do is this, followed by 2 square brackets. And this results in all the records from the body of the table being deleted. Now there is another way of clearing out the records of a table, and that's by using the refresh statement. And the syntax is super simple. All we do is say refresh and the table name. And by using this statement, you delete all the records in the table, but you still have to keep in mind your header record still contains values. It is untouched by the refresh statement. So just remember to use the clear statement that we defined first. Now before moving on, there's actually another statement. And this one is called the free statement. And as you might guess, this syntax is super simple again. All we do is type free and then the table name. Now, not only does this statement empty out the records from the internal table, but it also frees up the memory being used by your program. It doesn't mean your internal table no longer exists. It just means that it's been emptied out of memory. So if you need to access the internal table again, maybe to fill it with records, then you can do so. It's just that the program, when it does that, needs to reserve the memory space again. So the free statement does, the same job as the clear statement with the 2 square brackets and the refresh statement, but it has the added benefit of emptying out the memory used from your program. It clears it out, so it releases the memory to be used by some other process. And just like with the other 2 statements, the header line is unaffected, so don't forget to use the clear statement to clear your header line. Now let's take a look at deleting internal tables where we are using work areas. Work areas are fundamentally different structures that we set up in our program. Therefore, when we write some code that affects the internal table, it will never affect the work area at the same time. And also the reverse is true. Whatever code we write that affects the work area structure will never affect our internal table. When we're using internal tables with no header lines, some of the statements we have just been through will work a little bit differently. The clear statement, when used on a table without a header line, actually clears the whole table contents. Which sort of makes sense because I specified make sure you clear the header line, then you clear the table contents. But the syntax will work a little differently here. So if I show you, so if I say with header line here, then I'll copy this lot and show the differences with work area. So here, to clear out the header line, we would actually use this statement, clear, then the table name. We don't need the square brackets. But then we've got to keep in mind our work area is separate, so we have to clear that out as well. So all you need to do is use the clear statement again and then specify your work area. And let's say our example, our work area is set up as W8 itab 01. As we make our way down to the other statements, here the refresh statement, exactly the same stuff applies. We would have refresh itab 01 to clear out the table, which is exactly the same as with the header line. But you've got to remember, treat your work area differently because it's a different structure in its own right. And the same applies for free. The free statement will clear the internal table from memory, and then we would have to separately clear out our work area. Now this just about wraps up what we will cover on internal tables. We have been through all the major key topics that you will need to work with internal tables, both creating them, filling them up, and then destroying them afterwards. So take some time, practice, and get used to these commands because you will use them again and again and again in the programs you create. It's now time to take a look at one of the most important elements of an ABAP program, and that's dealing with internal tables. Now, you've already covered tables in the ABAP dictionary, and we've sort of hinted at internal tables throughout this course, but we haven't really dug deep into what they are, how we use them, and the syntax, and that's what we're going to do right now. If you are planning on writing any ABAP programs at all, or reading ABAP programs and really understanding them, you've got to understand internal tables. Because just about every program uses them. And you have to learn both the old method of using internal tables with header lines, as well as the newer method of using separate work areas. Why do we have to learn both? Well, SAP has been around a long time, and there are still a lot of programs in the system that use the old method of using header lines with internal tables. So when you're trying to recode, you've got to understand how they work. But when you're creating your own code, you want to use the newer method of creating separate work areas. And this will also make it easier when you move on to understanding ABAP objects. Now, internal tables only ever exist when your program is running. They're internal to a running program only. When you write your ABAP program, you specify the structure for an internal table, and you write your program to make use of it. And once your program finishes using the internal table, it is then destroyed. When you start to use internal tables in your programs, you will see that they behave exactly the same way as structures that you've defined in your program. And these structures are called work areas. The only difference is that your structures have only one line, whereas an internal table can have an unlimited number of lines, just like a normal database table. So let's ask ourselves, what is the use of an internal table? Well, internal tables are used for an awful lot of things in our programs. They allow us to hold results of calculations that we can use later on in our program. They allow us to hold records of data that we can access really quickly instead of having to read data from database tables over and over again, and a whole host of other reasons. Now, internal tables are really flexible because they can be defined using any number of other defined structures. This allows you to have many normal table structures grouped together and placed into one internal table. If you're familiar with other programming languages, think of multi-dimensional arrays. You will see as we work with internal tables that the basic form consists of a table body, which is all the records within the table, and then we have a header record. Now remember, the header record means we're working with the older style internal table. But for the newer style, we would have the table body and a separate work area, defined exactly the same structure as the table, but it is kept separate and works separately. Now flipping back to the older method, the header line or work area is used when we read individual records from our internal tables. And what do I mean by this? Well, when we read a record for the older style table, that record gets placed into the header record that we can access directly. For the newer style table, we read a record into a work area, very similar to a header record, but remember it's separate. And also when we want to add records to an internal table, for the older style, we place the contents into the header area. For the newer style, we place contents into the work area, and then we transfer the header record or work area into the body of the internal table, which results in us creating a new record. During this course, we have introduced the table statement, which we used to declare an ABAP dictionary data table that we wanted to work with. Now, internal tables are a little bit different in that we have to declare the internal table ourselves. And whilst we do this, we must declare if we want to use a header line as our work area or a separate work area. As I've mentioned before, you'll find that old SAP programs often use a header line with their internal tables, but today it's best practice to use a separate work area. You see, using a header line has several restrictions, and when SAP introduced the possibility to work with internal tables without header lines by using our own work areas, we were given the ability to create multi-dimensional tables, which, as I mentioned before, with the multi-dimensional arrays, it's just tables within tables. Now, we're not going to dig that deep into multi-dimensional tables in this course, but just bear in mind this can be done, and you'll find it used an awful lot. Now, I mentioned earlier that internal tables can have an unlimited number of records. Well, I told a bit of a white lie there. There are some restrictions. The architecture of an SAP system limits the size of our internal tables to around 2 gigabytes in size. You will also need to bear in mind just how powerful your specific SAP system is. Take into account the hardware, the operating system, the amount of memory there is, and so on. Even though we can create internal tables up to 2 gigabytes in size, it's best practice to keep them as small as possible, because if you have multiple programs taking up so much memory in your system, you'll run the risk of making your whole system run really, really slow. And the last thing you want is a basis guy coming up to you saying, "Why is your program taking up so much memory? You're causing everybody else's programs to run really slow." And the last thing you want is users complaining, because then you start getting some earache.